Hello everyone, I'm Aditya Rajat and my registration number is URK23CS1010. Today I'll be walking you through experiment 1, which is exploratory data analysis and data pre-processing. And in this experiment, we'll be working with a retail store dataset to understand customer behavior and prepare our data for machine learning models. So the aim of this experiment is to perform initial investigations on the dataset and apply various pre-processing techniques. So we'll be covering two main parts. Part A focuses on exploratory data analysis and part B covers data pre-processing, and I'll be demonstrating 30 different operations on the stores 1A and stores 1B datasets. So let me first show you the datasets we're working with. So this is the stores 1A.csv file, and it contains information about retail store transactions, and it has stuff like branch, city, customer details, gender, and so on. And this is a comprehensive dataset that lets us analyze various aspects of retail operations. Then let's start with the basic structure of our dataset. In question 1, we display the number of rows and columns using the shape attribute. And for question 2, we identify the categorical and numerical columns. So we use the select D types to separate object type columns from the number type columns. So this helps us understand what kind of analysis we can perform on each column. And for question 3 gives us summary statistics such as minimum, maximum, and mean for all numerical columns. So I'm using a simple loop to iterate through each numerical column and print these values. Uh, then for question 4, we'll calculate the 5 number summary for the age column, and this includes minimum, first quartile, median, third quartile, and maximum. So I'm using the quantile function to get Q1 and Q3 and median for the middle value. Then I create a box plot to visualize the summary. So then for question 5 and 6, basically question 5 and 6 focus on outlier detection using two different methods. In question 5, we use the IQR method. I calculate Q1, then Q3, then find the IQR by subtracting Q1 from Q3. Then the lower bound is Q1 minus 1.5 times IQR, and the upper bound is Q3 plus 1.5 times the IQR. So any value outside these bounds is considered an outlier. I display the row index and the outlier value for the quantity column. Then for question 6, we use the z-score method. So it tells us how many standard deviations the value is from the mean. So values with z-score greater than 3 are outliers. And I display both the value and its z-score. And the box plot at the end helps verify these outliers visually. Then correlation analysis helps us understand the relationships between variables. And so in question 7, I select 5 features: age, price, tax, and quarterly tax. Yep, age, price, tax, quarterly tax, and rating, and compute their correlation matrix. The correlation values range from -1 to 1, where values close to 1 indicate strong positive correlation, and values close to -1 indicate strong negative correlation. I also create a heat map using Seaborn to visualize these correlations. And the color intensity makes it easy to spot strong relationships. So for question 8 identifies the highest positive and negative correlations. I mask the diagonal values of 1 and find the maximum and minimum values in the correlation matrix. In question 9, basically filters for correlations greater than 60%. These are the features that have a strong linear relationship with each other. Then moving on to question 10. So skewness tells us about the symmetry of our data distribution. So in question 10, I analyze the tax column. A skewness value greater than 0.5 indicates right skew, less than minus 0.5 indicates left skew, and values in between suggest approximate symmetry. I also created a histogram with a KDE curve and a plot to visualize to visually confirm the skewness. So in question 11, I work with the categorical variable city using a bar plot. The bar heights show the count of observations in each city, helping us understand the distribution across different locations. Question 12 focuses on continuous variable rating. So I use two types of plots: a swarm plot that shows individual data points without overlap, and a violent plot that combines box plot features with kernel density estimation. This gives us both the distribution shape and the spread of values. Then question 13 shows a scatter of plot. No, question 13 shows a scatter plot between tax and cogs. Each point represents a transaction, and the pattern reveals how these variables relate. I also calculate and display the correlation coefficient. Then question 14 combines a categorical value, gender, and a continuous variable, age, using a box plot. And this shows how age distribution differs between male and female customers. So question 15 analyzes two categorical variables, gender and customer type. So I created a crosstab that shows the frequency count and a count plot for visualization, and this helps understand if customer type varies by gender. Finally, in part A, the final question 16 performs a multivariate analysis using a pair plot. So I selected five continuous features and used city as the hue to color code the points. And this creates a matrix of scatter plots showing relationships between every pair of variables with with histograms on the diagonal. Yeah, and this comprehensive visualization helps identify patterns and clusters based on city. So moving on to part B, which is data pre-processing. So question 17 identifies columns with missing values and calculates the percentage. This is crucial because our handling strategy depends on how much data is missing. So question 18 demonstrates mean imputation for numerical columns with less than 10% missing values. So I created a copy of the data frame first, then I replaced the missing values with the column mean. So here I showed the isNull.sum before and after to verify the imputation worked. So question 19 uses nearest method imputation, which fills missing values with the closest valid value using forward fill and backward fill. And question 20 handles categorical missing values using mode imputation. So replacing with the most frequent category. Yeah. So I showed before and after counts to confirm the imputation. Then for question 21 drops entire columns that have more than 10% missing values. So I identified these columns first, then I used the drop function, and yeah, then for question 22, I dropped the rows with outlier z-scores greater than 3 for the quantity column. So after calculating the z-scores, I identified the outlier indices and dropped those specific rows, and the shape difference shows how many outliers were removed. Then duplicate data can bias our analysis. So for question 23 basically it finds duplicate rows where all columns have identical values and calculates the percentage. Question 24 drops these duplicates and shows the size before and after. Question 25 takes a more nuanced approach, finding duplicates based on specific columns like customer, product line, age, and so on. And question 26 drops these specific duplicates and again shows the size change. So in question 27 performs min-max normalization on the age column. The formula subtracts the minimum and divides by the range, scaling values between 0 and 1, and I create scatter plots to compare original and normalized values. Notice how the pattern remains the same, but the scale changes. And in question 28 uses the z-score normalization, which transforms data to have mean 0 and standard deviation 1. The formula subtracts the mean and divides by standard deviation. Again, I compare original and normalized values using scatter plots. So question 29 demonstrates label encoding for the payment column using the scikit-learn's label encoder. Each category gets a unique integer. For example, cash becomes 0, credit card becomes 1, and so on. So I show the mapping and the first few encoded values. And question 30 uses one hot encoding, which creates binary columns for each category. For payment with 4 categories, we get 4 new columns where exactly one column has value 1 and others are 0. So this avoids implying any ordinal relationship between categories. So to summarize, we have successfully performed comprehensive exploratory data analysis and data preprocessing on the retail store dataset. And thank you.